Have you ever dreamed of building a rocket? Or maybe you own a model rocket or two and play Kerbal Space Program on the side. Well, this video is for you. Today, in our path to space, we are going to dive deep into the fundamentals of rocket design. Understanding this helps us recognize that these rockets we see on TV do not just appear out of nowhere, but instead they are made up of several unique systems designed by engineers. Before we get into the specific rocket systems covered in this video, let's first take a look at something called the design process and what it means. Just like any other product, the design of a rocket goes through several stages of planning, design, and testing before it comes to fruition. The first step that engineers take to design a rocket is to identify the customer requirements. These are the things that the rocket must accomplish. In other words, why are we building the rocket in the first place? That is the question we're trying to answer with the customer requirements. For example, some rockets are needed to deploy satellites, while others are needed to deliver humans to the space station. These are both examples of a customer requirement. The next part of the design process is the concept generation stage. This is where engineers will brainstorm to get an idea of what their rocket will look like and how it will work. The sky is the limit as far as coming up with ideas of how to accomplish the task. Finally, once a concept for the rocket is determined, the team will go on to designing and testing the specific systems of the rocket. That said, what are the systems of a rocket? While this video does not cover nearly everything about all the systems of a rocket, the larger systems that we are going to talk about are airframe, propulsion, and controls. Starting with the first one, the airframe of a rocket includes the shape and the form of the vehicle that determines its aerodynamic properties. That is, all the non-moving parts and shapes that affect the way the rocket will fly through the air. The task of designing airframes are usually placed in the hands of the mechanical and aerospace engineers. Their task is to design things such as the nose cone, the rocket body, and sometimes the fins so that the rocket will fly straight and have little drag force to slow it down. The second major system of a rocket is propulsion. After all, rockets are really just glorified drain pipes, unless it has a rocket engine to make it fly. Propulsion is defined by the systems of the rocket that give it lift. Yes, my friends, we are talking about the business end of the rocket motor. Typically, mechanical and chemical engineers will be the ones heading this system up. Their job is to decide what type of motor is needed and what kind of fuel will work best. The most popular types of motors include solid rocket motors and liquid rocket motors. As indicated by its name, solid engines are tubes of solid fuel that burn steadily and uncontrollably until there's no fuel left. These kinds of motors are found on almost all model rockets and some full-scale rockets. Perhaps the more widely used motor is the liquid fuel motor. This is where liquid fuel and oxidizer is mixed and ignited so that the expanded gases from the burning fuel shoot out the back of the nozzle at high speeds. This engine has the benefit of having control over the fuel and how much of it is burned, making it a very popular choice for modern rockets. The last major system we will talk about in this video is the control system. With the electrical and mechanical engineers taking charge, the control system includes anything that steers or manipulates the rocket. Control engineers are often responsible for designing movement control for the fins, or sometimes employing what is called vector propulsion. This is where the rocket engine itself points in different directions to steer the ship. Another crucial part of controls is the rocket staging. Staging is a term used to describe how the rocket operates in parts to get into orbit. For example, the largest rocket boosters of a rocket are often separated from the main body once they run out of fuel, revealing smaller engines that continue to push the rockets into orbit. Staging is necessary to lower the weight of the rocket, as parts of it are no longer needed once they burn out. While these three systems are fundamental to rocket design, there are many other systems that play a role in building all of our modern spaceships we see today. And, believe it or not, all of these engineering jobs responsible for these systems are totally available to you if you were to pursue the field. So, if you enjoyed this video, maybe engineering is right for you. Now that our rocket has its design, the only thing standing in our way of getting into space is the mission itself. That will be our topic for the next video. So stay tuned and join us in the next video of our path to space.